So let's read this. So there's a boat sitting in the ocean right here. Okay. And here's a restaurant. And the woman here wants to get to the restaurant as soon as possible because she has a date. And apparently this guy is pretty hot. And she doesn't want to be late because he might bail, right? So she wants to say, I need to get to that restaurant as fast as possible. What should I do? Should I sail directly to the shore and then walk this way? Or should I sail directly to the restaurant? Or should I go at an angle, stop, get off, and walk the rest of the way? What is going to be the fastest method? Okay, she's trying to minimize her time. So keyword, minimize the total travel time. So if that's what we're trying to minimize, we want a function of t. And then we take the derivative of that to minimize it. So now we have to think. There are two portions of her travel. First, she has to go from the boat to the shore. That's her first thing. And then she has to go from that point to the restaurant. That's her second part. So there's two parts of her travel. And so here's what we're going to look at. On the first part, there's distance 1. On the second part, there's distance 2. Now, we're also told her rate of travel. On the boat, we're told her rate is 2 miles per hour. 2 miles per hour. And then I'll call that rate 1. And then it's going to take her time. I don't know how much time. I'll call that time 1. Then to walk, we know her rate of walking is 3 miles per hour. But we don't know the time that it takes, so we'll call that T1. So for the ocean part, she has a distance to travel, she has a rate of travel, and she has a time of travel, right? Now, what you should know is distance is a rate times time. That's basic science. So you have to know that. If you didn't know that, you couldn't do this. And that's why they wouldn't give you this as an AP question, just because if you didn't get that, you wouldn't be able to do the problem, and it's not checking your calculus skills, it's checking your science and calculus skills. So fill in the knowns. We know her rate is 2, but we don't know her time, so we'll call it T1. And then for the walking, the distance she travels is the rate at which she travels times the time she travels. So all we know is her rate of walking is 3. Now, what are we trying to do? We're trying to minimize her time, right? What is her minimum time? And this is where it's going to get a little wacky here. We need to solve for T1 and T2. And her total time clearly is going to be time for 1 plus time for 2. Are we bueno on that? Okay, I'm going to change things around slightly to make our life easier. Okay, so instead, and you might hate me for this, why are we doing this? Because I choose to. We're going to call the distance from here to here, we're going to call that distance x. So in other words, where should she land? This many miles from the direct distance in. We'll call that x. Okay? If that's x, what's d2? That would make d2 equal to 6 minus x. Do you agree? Because if you take this total distance and you subtract that, that gives you d2. So you get 6 minus x. Is this going to make life easier? I don't know. We'll see. So we're going to get 6 minus x or D2. So what's T1? Divide both sides here by 2. T1 is D1 over 2. And what's T2? I should do a different color here. T2 is 6 minus x over 3. So that's the time it takes for each part. So the total time she takes will be D1 over 2 plus 6 minus x over 3. If your minds are exploding, don't worry. So here's a basic concept. We're trying to minimize the total travel time. So I need to function with time, and that's going to be this time plus that time. So I have to add 2 times together. Well, the time 1, we use rate times time is distance to get time 1 right here. And then for time 2, that should be a 2, by the way. For time 2, we do rate times time is distance. But then we change the distance 2 to the total distance minus that. And there's a reason why we're going to do that. So the main concept, we need an equation with time so we can minimize time. Now, if we were to take a derivative, we now have a big problem. Here's a problem. We have 2 variables, d and x. How can we take a derivative with 2 variables? That's bad. So we need to see if there's a relationship between those 2 variables, and that's where this comes into play. Let me pick a color. I haven't picked red. We have here a right triangle. Let me get rid of that fill. No fill. So we have a right triangle right here. And this is x, and this is d, and this is 4. So Pythagorean theorem applies. 4 squared plus x squared is d1 squared. That's my relationship. So 4 squared plus x squared equals d1 squared. That's why I got the x, so that I can have a Pythagorean theorem. Now, this might get very ugly, and I hope it doesn't, but I have a feeling it's going to. Now, I want to get rid of either that or that. So I have to solve for either x or d. I don't know which one's going to be easier. Let's solve for d. So I need to square root both sides. So I'm going to end up with d1 is the square root of 16 minus x squared. Okay? So I am going to take that and put it in for d1. That is what I'm trying to take the. I just realized this is a plus, not a minus. Good thing I saw that. I am so smart. Okay, so we're going to get a common denominator of 6. So this is missing a 3 over 3, and this is missing a 2 over 2. So our time is going to be 3, 16 minus x squared plus x squared square root over 6 plus 12 minus 2x over 6. Now that I have a common denominator, it's all over 6, and I get this. Okay? That's my function. Oh, I haven't taken the derivative yet, have I? Or did I? I am so baffled. I haven't. Okay, I need to take the derivative. I need to take the derivative. I haven't taken the derivative. So let me rewrite this for all of you. I probably should have taken the derivative one step earlier, but we're okay. I'm okay. You're okay. Let's take the derivative. Why are we finding the derivative? Because we know max and mins occur at critical points. So that's why we're taking the derivative. All right, 6 is a constant. I'm just going to leave the constant down there. So let's take the derivative of this. So we have a 3. We bring the 1/2 in front. It's box to the 1/2 power. So it's 1/2 box, decrease the exponent by 1, times the derivative of box. That's a plus, isn't it? Good thing I caught that again. That's a plus. I don't know why I keep putting minus. Then the derivative of 12 is 0, and the derivative of that is -2. That 2 cancels with that 2, so we're looking good there. Now we have our derivative. We have 3, 16 plus x squared to the negative 1/2, and there's an x too. See that x? So I put the x there. -2 over 6. All right, what are critical points? Where the derivative is 0 or does not exist. To be 0, I'm going to set the numerator equal to 0. And I'm going to rewrite it like this, because that is the numerator. The negative puts it to the bottom. I'm going to add 2 to both sides. Again, for those of you who are freaking out, as long as you're understanding the basic concept, I'm taking the derivative to find critical points. Don't worry about all the little details at this time. I'm going to multiply both sides by 16 minus x squared, or plus x squared, or the radical. Now I'm going to square both sides to get rid of the square root. So I'm going to get 3, I forgot the square there. So 9x squared, 4, 16 plus x squared. That's going to be what, 64 plus 4x squared. I'm going to subtract 4x squared from both sides. 5x squared is 64. Divide both sides by 5. Square root both sides. And it is plus or minus, but we're talking about distances, so we don't need the minus. And square root of 64 is 8 over radical 5. That is the distance that is suggesting that she should travel, like boat that distance down. Now we want to know if that's a maximum or a minimum. Now that is our only critical point. So if that is a relative max or relative min, it's actually an absolute max and an absolute min for our time traveled. So to finish this up, we're looking good with time. 8 over radical 5, that's our x. We want to know if the derivative gives us a relative max or relative min. Let me divide that to get a value. 8 divided by radical 5 gets us about 3.6. So I'm going to put a 1 and a number bigger than that, 5. I like those numbers. So is the derivative positive or negative around those? So we plug in 1 to the derivative. Okay, where's my derivative? Plug in 1. It's basically this over 6. So I'm going to plug in 1. That's positive. 1, that's positive. Uh-oh, we have a -2. I need to figure this out. I'm going to have to do this. 1, this is ugly. 1, that's going to be 3 on top, right? 1 there is going to be square root of 17, which is roughly about 4, right? Roughly 4. So 3/4 minus 2 is negative. So I can figure out that's negative. Let's plug in 5. That's going to, if we plug in 5 here, that's going to get us 15. 5 here is 25 plus 16, 25, 35, 41. Square root of 41. Dang. Square root of 41. I'm not smart enough to do that in my head. That's about 6.4. 15 divided by 6.4 is bigger than 2, so it's positive. Woo! What does that mean? That means the derivative changes from negative to positive here. That means t is a relative minimum here, But if it's the only relative extrema and it's a minimum, it's an absolute extrema. So the absolute minimum time occurs when x is 8 over radical 5. So that's our answer. At which point should she land? The point she should land would be 8 over radical 5 miles away from where she currently is. That is the crazy number 21.